All right, guys, this will be the last lesson for this week, and we're going to be covering solving rational equation here. Okay, so again, let's finish this off with a strong finish here. All right, so first thing we'll be covering is the essential understanding. So to solve an equation containing rational expressions, first multiply each side by the least common denominator of the rational expressions. Doing this, however, can introduce extraneous solutions. A rational equation contains at least one rational expression. You can simplify solving a rational equation if you first clear the equation of denominators. You can do this by multiplying by the LCD of the rational expressions in the equation. So forth here. This would be a rational equation here because, again, we have equations on both of these here, and so these work out, whereas this one does not have equations. So that's not considered a rational equation here. So anytime you multiply each side of an equation by an algebraic expression, it is possible to introduce an extraneous solution. So recall that an extraneous solution is a solution of the derived equation, but not a solution of the original equation. You must check all solutions in the original equation to confirm that they are indeed solutions. So again, that's the main thing you have to check for these here is you have to go back, plug your answers to see if they work out. So again, every time you get an answer, go back at the very beginning of your equation and plug in your answers to see if they work. And if they don't, then it's considered an extraneous solution. All right. So our first example here, solving a radical equation here. So here's our first example. Your first step is to always make sure that you factor if you can. So in that second equation over there, the x squared minus 9, you're going to use difference of squares. So when you factor x squared minus 9, as you see, you should get the factors of x minus 3 and x plus 3. Then from here, you're going to find the LCD of each one of these here. So the factors out of all of my denominators here, my factors, the LCD should be x minus 3 and x plus 3. So since that's my LCD, I'm going to multiply every single thing in here by x minus 3, x plus 3. The whole reason I'm doing this is because I want to get rid of those fractions. So again, in that first equation, I'm going to end up canceling out that x minus 3, and then I would multiply that x times x plus 3. And the second one there, I would cross out the x plus 3 and multiply that x times x minus 3. And in that, after the equal sign there, that denominator should end up canceling out because both those terms are the same. So what we should get here is when I multiply this out, I'm going to end up getting x squared plus 3x. I'll have x squared minus 3x, and then I'll have that equal to 2. Okay, after that, combine like terms. So on that left side there, those three x's are going to end up canceling out. 1x squared plus 1x squared gives me 2x squared. And then from there, that gives me equals to 2 because on the right side there, there's something we can combine with. Get the x squared by itself, so divide both sides by 2. X squared equals 1. Take the square root of both sides. Anytime you take the square root of a number, make sure you put plus or minus in front. So x is going to equal plus or minus 1. Then we go back. Since these are my two answers here, I'm going to go back and plug plus or minus 1 back into my original equations over here and see if they check out. So as we can see here, here's positive 1. So we have a negative 1/2 and we have a positive 1/4, and that should equal a negative 1/4. So again, if I were to type this into my calculator here, that ends up checking out. So again, that one works out. As we see here from negative 1, we end up getting a positive 1/4. We get a negative 1/2, and that should give us a negative 1/4. So from here, again, if you type that into your calculator, or if you look at your previous example here, that does check out. Again, you can type these into your calculator once you simplify it, but again, you have to go back and check. So since these both check out, that means that my solutions to this equation are x equals 1 and x equals negative 1. So again, that's the key thing. Once you find your answers, don't assume that they're always correct. Go back into your original equation, the one that we first started with, and plug in both of your answers. Okay? So I broke this part into two parts here, so we'll read our question, and then we'll go ahead and solve for this here. So a flight across the U.S. takes longer east to west than it does west to east. Assume that winds are constant in the eastward direction. When flying westward, the headwind decreases the airplane's speed. So when flying eastward, the tailwind increases its speed. The time for a round trip shown at the right is 7 3/4 hours. If the airplane cruises at 480 miles per hour, what is the speed of the wind? So as we can tell there, that's the distance from San Francisco to Chicago there. It's 1,850 miles. That's where they got that number from. So again, we're going to let x equal our wind speed here, and we're going to find rate times time equals distance. So again, we can rewrite that as time equals distance over rate. So again, to get time by itself, you divide by rate. That's how they got that equation there. So essentially, all we're going to do here is we know that the distance from both going to east to west will always be 1,850 miles, and that our rate will either be going west to east will be 480 plus x or 480 minus x, because we know going from east to west is going to increase your speed. Okay. So again, the way we got our equation here is we're going to take distance, which we said was 1850, over the rate, which we said was going to be both of these right here. So that's how we got our time. So again, it's just putting it as distance over rate. Okay. Now using this here, our two time parts right there, we're now going to rewrite this, right? Again, these are just the two times that we had. So we have our total time equals time west to east plus time east to west. So again, the total time that we said was 7 3/4 hours. So that's 7.75 hours right there. So again, we've already set this up as our equation here, because again, we are trying to solve for x. So our first step here is to find our LCD. So since these are different, that means that the LCDs are going to be both of these right here, that 480 plus x and that 480 minus x. So I'm going to multiply both of those into all three terms there. So again, as we can see here, I multiplied all three terms into that 480 plus x and that 480 minus x into all three terms. So in the first one, we're going to have to FOIL that out two different times, right? And then here on both of these on the right side here, we're going to have on that first one where 40 plus x will cancel the denominator out. And on the second one over here, we'll have 480 minus x cancel that denominator out. So essentially, we're just distributing that 1850 into just one of those factors. Very simple there. So when simplified here, we should get 1,785,600 minus 7.75 x squared. And on the right side, when all combined, should give us a negative 9. What we have right here is when we combine these right here and then subtract that 1,785,600, those end up canceling out. Or not canceling out, it ends up leaving us with negative 9,600 there. Those x's are the ones that cancel out. From there, again, we're trying to get x by itself. So I'm going to divide here by my negative 7.75 x squared. And again, from there, we end up getting our number, and then we take the square root of that number. From there, then we have our plus or minus. So again, we cannot have a negative, wind speed. So again, that essentially tells us that the only answer that we can have is a positive wind speed, which is 35. So that means that the west to east wind speed is right around 35 miles per hour. Okay. Again, you can't have a negative wind. That's why they got rid of the negative answer there. Okay. All right. Last example here, guys. Last example, and I'm going to show you how you can use a graphing calculator to solve a rational equation. So again, here's our equation right here. So what we're going to do is on one side of the equation, we're going to enter that into our y1. So that left side, everything that we see right there, I'm going to type that into my y1. So again, make sure you're careful with those parentheses also, because if you put a parentheses in the wrong way, guys, then it's going to mess everything up. So I would highly recommend that you put parentheses like around the x plus 2 and like around that x minus 2, because if you miss one little thing, it's going to give you the wrong answer. Okay. So you type one side on the y1, and then the right side, that one will go in our y2. So again, you're typing both sides into each separate equation there. Then we're going to graph it. Again, there appears to be only one intersection. As we can tell, that intersection happens at x equals 0. So if I go to my table here, I'm looking for when my y1 and my y2 are the same answer. And again, as we can tell here in our table here, y1 and y2 are both at 1 right there, and that happens when x is at 0. So that means, since they have the same answer right there, that our solution is going to be at x equals 0. So when I go back and I plug that into my equation right here, remember, I'm going back to my original equation. Wherever I see an x, I'm going to plug in 0. When I simplify that, that ends up giving me 1 plus 0 equals 1. And again, 1 plus 0 gives us 1, 1 equals 1, so that checks out, which means our answer here is x equals 0. If it doesn't check out, then that means you have an extraneous solution, and that cannot be one of your answers. Okay, so that's it for today, guys. You will have homework over this. Your homework will be due by Friday, May 1st. Again, we're already in May, guys. That's crazy. By 11:59 p.m., make sure you're staying on top of your assignments. And as always, if you have questions for me, please feel free to contact me. Go through Remind, go through email, whatever you need to do to get in contact with me. I'll find a way to get back in touch with you. Other than that, guys, that's it for today's lesson. You guys stay safe. And again, if you need anything, I'm here for you. Y'all have a great day.